We are solving exponential equations today. There are three different types of exponential equations we're going to look at. We're going to look at two examples of each of those. So solving exponential equations today. What? What's that? Alright, I have 4 to the x plus 7 equals 8 to the x plus 3. Now I want to solve this exponential equation. Any thoughts on what I need to do? I need to make the bases the same. So when I have an exponential equation and it has two exponential parts, I want to try to make the bases the same. So what base do I want to make? Okay.
I mean 2.
Now, the base can never be bigger than the smallest base. So in this case, my base cannot be bigger than 4. But remember, you've got to choose something that can be raised to a power to get what you have. So I cannot do 4 to some power to get 8. Okay, I need to do 2. So this over here is 2 squared. And this one over here is 2 cubed. Natasha?
Yeah.
Get your hand ready.
Oh, no. I was doing 2.
Alright, then, as we've done before, once my bases are the same, what does that mean? The exponents are the same. So distribute the 2, that's 2x plus 14 equals 3x plus 9. And then we just solve from there. So subtract the 2x, which gives me x, subtract the 9, gives me 5, and we get x equals 5.
It's the exponent. Yeah, the exponent. You just did the exponent. Like, since these are the same.
Oh, crap.
And then you solve.
So if I've got an exponential equation and I have 2 exponential pieces, we want to try to do what? Get the bases to be the same, set the exponents equal, and solve. Okay, that's the first type. So let's do another one like that. Alright, my next one, I have 9 over 16 raised to the 4x minus 3 power equals 3 over 4 raised to the 5x plus 4 power. So we should notice we've got 2 exponential pieces in this exponential equation, which means we want to try to do what? Get the bases the same. So what do our bases need to be?
Wait, aren't
9, 16.
yeah, aren't they the same though?
They're not the same.
3 to the 4th square.
Alright, now, when you have fractions, it may get confusing. So if it gets confusing, just look at one part of the fraction. Just look at this, and look at that. So what do the bases need to be for the top? 3. And I look at this, and I look at that. What do my bases need to be for the bottom? 4. So we should notice that my bases need to be 3/4. So then I ask myself, 3 to what power gives me 9? 2. So that means this is 2 and 4x minus 3. This over here stayed the same, so my exponent stays 5x plus 4. So my bases are equal, which means the exponents have to be equal. So that gives me 8x minus 6 equals 5x plus 4. Subtract the 5x gives me 3x. Add the 6 gives me 10. So that means x has to be 10/3. Question. Now, there's going to be one in your assignment today, and instead of getting this, it will give you something like 16 over 9, 4x minus 3 equals 3 over 4, 5x plus 4. Any thoughts about that? What'd you say?
Negative flexible.
Alright, so that means I need the 9 to be on top and the 16 to be on bottom, and as Nick's saying, what is he saying? I make my exponent negative, and that will flip it for me. So keep that in mind whenever you come up with that. Alright, so there's the first, very good, Nick. There's the first example, or the first type of exponential equations. Here's your next one. You'll need your calculator for this, so go ahead and get it. I have 7 raised to the 2x plus 1 equals 3 raised to the x plus 3. Alright, so we should notice that this is an exponential equation and it has 2 exponential parts. So what do we do whenever we have 2 exponential parts? Try to get the bases the same, but what's the problem with this one? Not possible. So when it is not possible, there is a 6-step process to solve this equation. Okay? It's not hard, there are just 6 steps to it. The first step is to take the natural log of both sides. So that's step 1. Step 1 is to take the natural log of both sides. Any ideas on what step 2 needs to be?
Combine.
No. I appreciate the explanation. What else?
Figure out how to get one equal to.
Nope.
You need to make your exponents equal.
Awesome. Move the exponents. Very good. So step 1 is natural log of both sides. Step 2 is move the exponents. Thoughts on step 3?
Isolate the logs.
Eventually, we're going to do something similar to that.
What is set the exponents equal to?
Nope. Any other thoughts? I'll take one more educated guess before I show you.
What was trying to make the exponents the same?
No, we don't have any exponents anymore.
Oh.
That is true.
Don't have any exponents.
The coefficients that you was doing.
Alright, what we want to do is we want to distribute on both sides. So distribute your log on both sides. So this gives me 2x natural log of 7 plus the natural log of 7. On the right side, x natural log of 3 plus 3 natural log of 3. So step 3 is distribute.
It's like straight.
Step 3 is distribute. Now what? Correct.
You add
I need a goal. Somebody tell me what my goal in the next step should be.
Get the X's on them.
Very good. If it's got an X in it, I need to get it together on the left. If it doesn't have an X in it, get it together on the right. So I've got 2x natural log of 7 minus x natural log of 3 equals 3 natural log of 3 minus natural log of 7. So that's step 4. Step 1 is natural log of both sides. Step 2 is move the exponents. Step 3 is distribute. Step 4 is get the x's together on the left, everything else on the right. Step 5. Nicholas,
Step 5?
did you have something to say?
I didn't.
No? Okay. What else? What do you think?
Move it back to knots.
What am I trying to do? What's my goal?
Get
I'm trying to figure out what x is.
Fraction.
I'm trying to figure out what x is, so what do I do now?
You made the equal
I don't wanna do that.
Only,
Not fraction.
only.
No, not yet. Eventually.
Then it's like,
I guess it's good. This is
the letter 7.
Can you divide or? Oh, this is seven.
Buen enchilada.
So what did I do there?
Factor out the-
Factor out the x.
Oh, there you
So
go.
step 1 was natural log both sides. Step 2 was move the exponent. Step 3 was distribute. Step 4, get the x's together on the left. Step 5, take the x out. Step 6,
Divide by 2 ln's.
very good. Step 6 is divide. So 3 natural log of 3 minus the natural log of 7 over 2 natural log of 7 minus the natural log of 3. And then we plug it in our calculator, and how many decimals do we want? 3. So, what's the best way to put that in your calculator? What are we going to do to get started? We're going to do control divide. We're going to put this in the top. We're going to put this in the bottom, and then we're going to press enter. So somebody do that for me real quick.
Why is the?
Why is what?
Okay.
So what's this?
4 sub 6 is to divide.
You should be getting 0.483 in your calculator
Oh, no.
when you do that, Sky.
Did you get the right side on the numerator? Or was there a reason
Well, I gotta get x by itself, so that means this right here has to be divided to that side, so this means that's the numerator,
why? Okay,
that's
I
the
did.
denominator. So punch that in, I get 0.483.
Nice, what's steps?
So,
Under step six, you put count of you calculator.
I'd say divide and calculate. Divide and use calculator.
Oh, I did that wrong.
Alright, one more
wait.
on that time. Alright, so I have 3 to the 4x plus 3 equals 8 to the negative x plus 2. So when I look at this problem, first thing I should try to do is what?
Takes it.
Try to get the bases to be the same. That's the first thing I should do. I should realize that I can't do that, so that means I gotta do the natural log deal. So step 1 is natural log of both sides. So natural log of 3 to the 4x plus 3 equals natural log of 8 to the negative x plus 2. What's step 2?
That's
Do the exponents. So 4x plus 3, natural log of 3, negative x plus 2, natural log of 8. Step 3, distribute. So 4x, natural log of 3 plus 3, natural log of 3 equals negative x, natural log of 8 plus 2, natural log of 8. Step 4, get the x's together. So 4x, natural log of 3 plus x, natural log of 8 equals 2, natural log of 8 minus 3, natural log of 3. Step 5, factor out the x, very good. Step 6, divide, very good. So put that in for me.
Yes, buddy.
Anybody get it?
No.
I got x equals 0.133. That's what I got. You got something different, Brandon?
Yeah, I got 161.
2 natural log of 8 minus 3 natural log of 3 over 4 natural log of 3
Oh,
plus natural log of 8. What'd you do?
I put 3 natural log of 3 natural log.
Alright, so that's our second type. Here's our third type.
Lies.
Alright, so our third type of exponential equation is 4 to the x plus 4 equals 17. 4 to the x plus 4 equals 17. So what do we notice about this one?
There's only an exponent on one side.
There's only one exponential part. Okay, so make sure you notice that's the main difference between the first two. On this one, there's only one exponential part. So if I have one exponential part, what do you think our approach should be?
Subtract 4.
Subtract 4. Right, that's what I'm looking for. Get the exponential part by itself. If you've got one exponential part, the first thing you want to do is get it by itself. So in this case, I want to subtract 4, which gives me that. So if you've only got one exponential piece to your exponential equation, you want to get it by itself. Once it's by itself, then what are you going to do?
See if you can get the pieces the same.
You can try that,
Make it a log.
but it won't work. So then what?
Make it a log.
Make it a log. So what do I need to identify to make it a log, Blake?
Base.
Base and the exponent. So what's my base?
4.
4. So I can do log base 4. What does the log have to equal?
Yeah.
Which is
X.
x. So that means 13 has to be there. So all I have to do is plug that into my calculator, and that tells me what x is. This one's probably the easiest, yes. Okay, so, and I want to show you something. If you do log base 4 of 13, we end up with 1.850. Well, let's say you don't have a fancy calculator like you have to where you can put in the base and put in what's inside of it. You can always do the natural log of what's inside divided by the natural log of the base, and that will give you the same answer.
Okay.
So the natural log of what's inside divided by the natural log of the base will give you the same answer. So if you have your iPhone or whatever phone you have, and you want to use that calculator, you can do it. Okay. So 1.850 is what we get there. All right, one more. Okay, I have 3e to the 4x minus 5 equals 40. Plus you. Alright, I want to solve this. So what should we notice when we first look at it? There's only one exponential part, so what do I want to do? Right, I want you guys to give me the goal. Thank you. Get the exponential part by itself. So 3e to the 4x equals 45. Then what? No,
Get the natural log.
no,
Move the exponent.
no.
Divide by 3.
Divide by 3. Because the exponential part is not by itself yet, so I've got e to
Oh,
the
so you can
4x
do that?
equals 15.
That's fantastic.
Now I can change form. So my base is e, which means it turns into natural log. What is the natural log going to equal in this case? 4x, which means 15 has to be there. What do I do with that 4 in front of the x? Divide, but since I'm dealing with logs, how does it look? I put a 1/4 over here. So 1/4 natural log of 15 equals x. And I punch that in my calculator. I think I've got it punched in. So 1/4 natural log of 15 gives me 0.677. So 0.677 is x. So when you're solving exponential equations, what's the first thing we want to identify?
How
No.
many exponential parts?
How many exponential parts do you have? If you have two exponential parts, the first thing you want to do is
Try to make that equal.
try to get the bases the same. If you cannot get the bases the same, then what do?
Take the
Six
natural
steps.
log.
You do the 6-step natural log process. If you only have one exponential piece, what do?
Do the exponential.
Get the exponential part by itself and then do what?
Make it 12.
Change forms and solve and use your calculator. Very good. All right. All right. So page 196, 2, 4, 8, 30 to 36 even, 40, 42, 46, and 48.